Good morning to all of you. Today we are going to discuss about the multiplication of two determinants. For the multiplication of determinant, order of both the determinant should be equal and multiplication of two determinant we can apply row by row method, row by column method, column by column method and column by column methods, so that there are four types to multiply the two determinant, but one is exists. Order of both determinant should be same. Whereas we study in the matrix, their multiplication only applicable row by column method, but in the determinants, multiplication of two determinants, we should solve the any one methods of the four methods: row by column, row by row, column by column, column by row. Here now multiplication of two determinants, order of now here multiplication of two determinant, we first order of determinant should be equal. It means that order of determinant 2 cross 2, it means that 2 row and 2 column, 3 cross 3, 3 row and 3 column, 4 cross 4, 4 row and 4 column, only applicables. It does not applicable 3 cross 2, 2 cross 3, 4 cross 3 and so on. And second condition, multiplication of two determinants, we apply any one method of the following: first, row by column method; second, row by row method; third, column by row method; and fourth, column by column methods. It means that we can use any one method of these four methods. The value of determinant must be same, equal. Note here in the matrix, for the multiplication only apply the row by column methods. About the matrix we study in the further videos. Now we take an example. One determinant here A1, B1, C1, D1. Here L1, M1, N1 and P1. Now we apply here row by column methods. Multiply row by column methods. Row by column method. Here row by column methods, it means that this first row, second row, first column, second column, so that row by column method here, row by column method A1, L1, A1, L1, row by column method A1, L1, B1, N1 plus B1, N1. Now second A1 M1 A1 M1 plus row by column B1 P1 B1 P1. Now row by column method, we take this row, first row, second row, C1 column C1 L1 C1 L1 row by column C1 L1 plus D1 N1 D1 N1, and second element here C1 row by column C1 M1 C1 M1 plus D1 P1 D1 P1. This is also order of this mathematics is 1 to 2 row and 1 to 2 columns. Order of this is order equal to 2 cross 2. Now this is the multiplication of these two determinants. Now here prove that A1 L1 plus B1 M1 A1 L2 plus B1 M2 A1 L3 plus B1 M3. Here A2 L1 plus B2 M1 A2 L2 plus B2 M2 A2 L3 plus B2 M3 A3 L1 plus B3 M1 A3 L2 plus B3 M2 A3 L3 plus B3 M3 equal to 0. Now from left hand side, here this A1 L1 plus B1 M1 A2 L1 plus B2 M1 A3 L1 plus B3 M1 Here A1 L2 plus B1 M2 A2 L2 plus B2 M2 A3 L2 plus B3 M2. Here this A1 L3 plus B1 M3 A2 L3 plus B2 M3 A3 L3 plus B3 M3. Now from the left hand side, now we see this determinant. We can write here A1 A2 A1 A2 A3 A1 A2 A3 A1 A2 A3, and in this case B1 B2 B3 B1 B2 B3. This we take this 0 here and multiply of the here L1 L2 L1 L2 L3 L1 L2 L3. In this case L1 L2 L3, and now here M1 M1 M2 M1 M2 M3, and take here 0 0. Now in this case If we multiply this, comes here row by column methods. A1 row by column methods. Now A1 row by column A1 L1 plus B1 M1 plus 0 0. It means that A1 L1 plus B1 M1 plus 0 0. These terms here row by column method first. Now second here row by column. Write in this case A1 L2 plus B1 M2 plus 0 into 0, so that this terms here. Now A1 L3 here, B1 M3 here, and 0 0, so that no change. Now first row complete. We take second row by column methods. A2 L1 plus B2 M1 here, and 0 into 0, so that these terms here. Now second row, second column, A2 L2 plus B2 M2 plus 0 0, and now this A2 L3 plus B2 M3 plus 0 0, so that first row complete, second row complete. Now third row, here row by column method. This here A3 L1 plus B3 M1 plus 0 0. Then A3 L2 plus B3 M2 plus 0 0, and again A3 L3 plus B3 M3 and plus 0 0. Thus we can divide this single determinant in the form of two determinant, and if we apply the row by row methods, here row by column methods, row by column method, we break down this determinant here in this form. Now in this form, now we see here this is A1 B1 0, A2 B2 0, A3 B3 0, and here we this. I know that if you expand the determinant through any row or any columns, that will be same. So that if we expand with the help of first row, first column, second column, third column, the value of this is equal to 0, and here first row, second row, third row, with the help of third row, so that this is also equal to 0, so that total equal to 0, and as you prove this is equal to 0, this is right hand side root. Proved here. Now similarly we multiply the row by column method. Row by row method, if you apply row by row method, first row, then first row, second row, first row, third row, and so on. Now here solving system of linear equation. Here by the Cramer rule, this with the help of this rule we solve the linear equations. Linear equation in two variables a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Here x and y are variable and A1, B1, C1, A2, B2, C2 are the constant. Here D equal to here D the determinants and equal to A1, A2, B1, B2. This is a D, and D1 equal to we replace A1, A2 by the C1, C2. A1, A2 replaced by the C1, C2, and B1, B2 is same, and D2 is A1, A2, B1, B2 replaced by C1, C2. So we get the value of determinant D, D1 and D2. Then after that we find the value of X equal to D1 by D and Y is equal to D2 by D. As we study about this here, where A1 by A2 does not equal to B1 by B2 in this case. Now, type of the solution in this case. Type of solution in this case, a unique solution as we study in the linear equations. A1 by A2 does not equal to B1 by B2. In that case, we solve the linear equations. In those cases, D does not equal to 0 and no solution. As we study about this in the linear equation, A1 by B1 equal to A1 by A2 equal to B1 by B2 does not equal to C1 by C2. So that in this case, no solution. And infinite solution, it means that we study in the linear equation A1 by A2 equal to B1 by B2 equal to C1 by C2. It means that value of determinant D equal to D1 equal to D2 and value of these three determinants that is equal to 0. So that in this case the linear equation has infinite solutions. And now we take the linear equation of three variables here. Linear equation of three variables. Linear equation of three variables here. A1x here A1x plus B1y plus C1z equal to D1 A2x plus B2y plus C2z equal to D2 A3x plus B3y plus C3z equal to D3. In this case, x, y, z are variable quantity, so that its name linear equation of three variable, and A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3 are the constant. And so that let us suppose that this is the first equation, this is second equation, this is a third equation. Now solve this linear equation with the help of determinant D equal to, here we can write D or delta both. Now D equal to, here A1, A2, A3, A1, A2, A3, B1, B2, B3 and C1, C2, C3, C1, C2, C3. This is the determinant D. And now we replace A1, A2, A3 because for the value of X, we replace A1, A2, A3 by the D1, D2, D3, so that D1 equal to, here D1, D2, D1, D2, D3, B1, B2, B3, B1, B2, B3 and C1, C2, C3. Now here for value of x, for value of y, D2 equal to we replace B1, B2, B3 by D1, D2, D3 in this case, so that first column A1, A2, A3 and this is D1, D2, D3, C1, C2, C3 and now for value of z, here D3 equal to this is replaced by this quantity, so that A1, A2, A3, B1, B2, B3, D1, D2, D3. Now with the help of these linear equations, convert it in the form of determinant and x equal to, as here x equal to D1, D2 replace in this, so that x equal to D1 by D, x equal to D1 by D and y equal to here D2 by D and z equal to because z equal to this is replaced by this, so that D3 by D. Now for putting the value of D, D1, D2, D3, we get the value of variable quantity x, y and z easily. And now here note, Cramer rule can be used only when d does not equal to 0, because if d is equal to 0, then the value of x, y, z become infinity, so that Cramer rule only apply where d does not equal to 0. Solution in this case, as we see here, x equal to D1 by D, y equal to D2 by D and z equal to D3 by D here. In this case, if d does not equal to 0, it means that consists of a solution, it has solution. But if d equal to 0, at least one of D1, D2, D3 is a non-zero, so that it has no solutions. It means that d is a 0, value of determinant will be 0 and इसमें से किसी एक is a non-zero, so that no solution and system of equation will be in the inconsistent. But if all the 0, D0, D1, D2, D3 are 0, all the 0, D0, D1, D2, D3 are 0, so that it has infinite solutions. And here, if at least of D1, D2, D3 is non-zero, so that solution is unique solution and non-trivial solutions, that solution are separate, a value of x, y, z are separate. But if D1, D2, D3 equal to 0 and D does not equal to 0, then the solution is unique and that is a trivial solution, because the solution of x, y, z are the same here. Now we see an example. Now here one question here: if the system of equation alpha x plus y plus z is equal to alpha minus 1 x plus alpha y plus z is equal to alpha minus 1, x plus y plus alpha z equal to alpha minus 1 has no solution, then alpha equal to what? First of all, we see that if the value of d is does not equal to 0, then it has solutions. But in the second case, if d equal to 0, at least one of it is non-zero, that it has no solution. And has no solution, it means that for no solution, d must be equal to 0, because we putting the value of d so that it become infinite. So for no solution, has no solution, d equal to 0, and d is the determinant of formed by this alpha coefficient of this one, coefficient of this one, coefficient of this one, coefficient of this alpha, coefficient of this one, coefficient of this one, coefficient of this one, coefficient of this is alpha, so that value of determinant d equal to this, d equal to this. For no solution, d equal to this, it means that d equal to this term. We apply here R1, this is a R1 replaced by now R1 minus R2, here C1 replaced by C1, C2, C3 replaced by C1 minus C2, and C2 replaced by C2 minus C3, We apply this C1 replaced by this is C1, C2, C3. Here this is equal to C1 minus C2 and alpha minus 1. Here alpha minus 1. C1 replaced by C1 minus C2, alpha minus 1. In this case, 1 minus alpha. In this case, 1 minus 1 equal to 0. And here C2 replaced by C2 minus 3. 1 minus 1 equal to 0. Alpha minus 1. And this is 1 minus alpha. And this is unchanged 1, 1 and alpha. जैसा कि हम जानते हैं कि एक साथ जो है सभी रो या सभी कॉलम को परिवर्तित नहीं किया जा सकता है। एक कम से कम एक रो और एक कॉलम को छोड़ देंगे, जिससे कि डिटर्मिनेंट के मान में कोई अंतर नहीं आएगा। So that we apply C1 replaced by C1 minus C2 and C2 replaced by C2 minus C3. This is equal to 0 here. Now here alpha minus 1, it can be also written as with negative sign alpha minus 1, so that this become alpha minus 1. Here we take the common alpha minus 1. And 1 here also take the common alpha minus 1. Now here alpha minus 1, here alpha minus 1, then minus 1, here 0. In this case, this is a 0, this is 1, and this is alpha minus 1 and minus 1, and here 1, 1. And alpha equal to 0. Now we expand this here, right? Alpha minus 1 का स्क्वायर and we extend this row or column, it means that here we take this 1, deleting this and this, only this 1 1 1 1 minus 1 alpha. Now here alpha minus 1 का whole square, and we extend along the first row 1 here, deleting this and this 1 1 minus 1 alpha plus minus 0, so that this becomes 0, plus minus plus 1, deleting this and this minus 1 1 0 minus 1 minus 1 1 0 minus 1. Now here in this case cross multiply alpha minus with minus 1 into 1, that is plus 1 alpha plus 1. Here value of this is equal to 0 and this in this plus 1 and minus 0, so that this here alpha plus 1 and plus 1 alpha plus 2 and alpha minus 1 का whole square. If alpha minus 1 का whole square equal to 0, then alpha equal to 1, and if alpha plus 2 equal to 0, alpha equal to minus 2, so that alpha will be 1 and minus 2. Now like and subscribe my videos and share with your friends. आप हमारे वीडियो को अभी तक यदि सब्सक्राइब नहीं किए हैं तो सब्सक्राइब करें, ताकि प्रत्येक दिन आपको किसी वीडियो का नोटिफिकेशन मिलता रहे। थैंक यू।